Right. So we have anyways. This is the first slide. So this slide should remind you all that the origin of the charge is in the atom, electrons, protons, right? And all matter is made up of atoms, right? And so all the matter carry charges, right? And then we have seen the concept of free electrons. And then here we understand that, well, the current, see now understand from this diagram what? There are charged particles, they can be made to move by another charged particle. A charge creates electric field and magnetic field, and the very charge is also affected by the electric field and magnetic field created by other charges. This charge has created electric field, and when it is in motion it has created magnetic field. Another charge will get influenced by the field created by this. The electric field created by the charge will not influence itself. Understand? It will affect other charges. And how it affects? Well, it creates a region of influence, which you call it as the electric field. And electric field is not just, like it's a notion, it's a reality, right? And we have characterized that by showing electric field vectors, whose length is equal to the force experienced by the electric charge, unit electric charge placed at that point, and it is directed towards it is in the radial direction. If it is same pole, it gets repelled. If it is like pole, it will get attracted. Right. See, you should be able to get hold of that. And two types of charges are created. Right. They repel, they attract, and then the tribolic series. Just an information where you can create charged bodies. Right. And then of course the good representation of the gravitational field of Earth. I am showing gravitational field of Earth because you are familiar with it. I can't show electric field here, but all of us can feel gravitational field. We can understand gravitational field because it is around us, and electric field is also similar to that. Here mass is creating gravitational field. Here charge is creating electric field. Right? One mass will attract another mass. Here one charge will influence another charge. I am not using the word attraction. If there is a positive charge and then there is a negative charge, the field created by the positive charge will attract the negative charge. If there is a negative charge and there is a negative charge, the field created will repel. If there is a positive charge and a positive charge, the field created will repel. And not saying anything, if I say what is the field at this point, the test charge that you are going to use will always be a positive charge. If I say, oh, consider a negative charge, then if I simply say consider a charge, it means it is positive charge. Alright. Then I have explained this gravitational field for all of you, right? Okay. Then you can see there are different fields. Right now I demonstrated to you. Right now here we have got two fields. One is gravitational field, other is the magnetic field. The magnetic field is like this. The gravitational field is like this. So if I keep a bar magnet here, it will have both the influences. Due to gravitational field, it will tend to accelerate downwards. Due to the magnetic field, there is force in this direction. So now you can calculate the net force on the bar magnet. If I keep a pen or something here, it will only have gravitational field. It will be influenced by gravitational field. It will not be influenced by magnetic field. Right. And if I create a hypothetical object which only has magnetism and no mass, right? Now don't ask me anything like that. Assume, then it will only be influenced by magnetism. Then this is important. Electric charge is intrinsic property of such plant which due to which it produces and experiences electric and magnetic rates. Very important. Now here I continue the journey. Now the intention is now, you see, this electric field will manifest. I mean, you will feel the presence of electric field under different situations. In different situations, the electric field will manifest in different manner. That is, its action. What does it do? What will the electric field do under different situations? That is what we are going to understand. Right? Now, in this situation of metal rod, the electric field in the metal rod will push the electrons in the free electrons in the metal rod. The free electrons in the metal rod will act like charge carriers and the bulb glows. Now, even though in glass rod there are atoms, but there are no charge carriers, therefore it will not help the bulb to glow. The electric field has no effect on glass rod. Right? Just an idea. You will have a better idea now when we talk about conductors and resistors. So here I have shown a typical example of what happens inside a battery. Right? A chemical battery, chemical reactions occur, and there are two types of charges here, the positive charges and the negative charges. The positive charges are due to the ions. Negative charges are also due to ions. Inside the battery the conduction is not because of free electrons. Outside the battery the conduction is only because of free electrons. What did I say?
Inside the battery.
Battery, it is only free electrons. Clear? All these are important. You start understanding it better and better as you learn more. Now I have shown you the
inside the battery there is no free electrons.
There are no
free electrons.
No. See, I didn't say there are no free electrons. The conduction is predominantly because of the ions. That's what I said. I did not say there is no free electrons. Understand? There may be, there may not be. But predominantly the conduction is because of this. Okay? Right. So that's right. We have to use our words very, very carefully. Right? So if I don't say something about it, then that you have to apply your mind and understand what it is. See, there are two things. One is knowledge, another thing is wisdom. See, we might have knowledge, but we must have the wisdom to use the knowledge. Understand? That's important. So both these things are important. So therefore now, when I make a statement in physics, you should very deeply understand that statement. Current is predominantly because of the ions inside a battery. So whether there is electrons or no electrons, etc., well, I am not speaking about it at this stage, because to learn battery, well, you need hours. You need many hours. You need to understand electrochemistry. You need to understand all the substances that are present. So it's a very complex. Anything that we are learning is very complex. There is nothing like simple. In high school, what you are learning here is very simple. The mathematics you are learning is very simple. But now I will show you some books of mathematics. Okay? You will learn mathematics in high school. You will in PUC 1 and 2, again you will learn mathematics. 4 volumes of mathematics. And then when you go to engineering, whether you take civil engineering or electronics engineering or mechanical engineering, you will have minimum 4 semesters of mathematics. Minimum. Then only you can learn engineering. And then again you have to learn more engineering, you have to learn more mathematics. Right? And some people only learn mathematics in BSc, MSc and PhD and beyond. So much of things are necessary. So legally, frankly speaking, world is very complex. All these systems are very complex. We are creating very idealized condition so that we start understanding it in bits. Alright? That's it. So at this stage, you have to understand it ideal conditions. We are not going to the depth of what's exactly happening inside the battery. My contention is, well, the conduction inside the battery is predominantly because of the ions. And outside it is due to free electrons. That's it. Anyways, good that you asked. Such questions you ask. Huh? When I show some diagram and I'm explaining something, you can ask such questions. Right? It should be pertaining to that. Right? You should not take me to space and some places. So this diagram was not necessary, but I had to show this diagram because you had a lot of questions to ask about conventional current. Because in fact, I remember my college days, I said, why the hell, if electrons are going like this, you have the current also in this direction. Why do you want to create confusion? Right? Yeah, it was allayed because of this. I suppose it is clear, right? And again, I have shown you, now here we are defining the next level. First we have understood what is charge, and now we have also understood that for a bulb to glow, you need a electrical energy source, and then there should be a conductor to use the electrical energy to transfer it to the bulb, and then we understood that there is current, and now we will understand what is current. We said, okay, it's moving, current is there. What is this current? Well, so the definition of current, well, net rate flow of electric charge. I suppose I made this clear. And the second part is the strength of electric current. Okay, so the quantity of charge moving across a surface, okay, in unit time. If large amount of charge moves in small time, the strength of current is more. Right? If large amount of charge moves in more time, then the strength of the current is less. Okay, I suppose you understood what I meant. Again, it's quite complicated, but this stage, just understand it like this, things become simple. Now I have elaborately explained to you what is the natural current and what is the conventional current. So any current, whether it is negative charges moving or positive charges moving, you first convert it into conventional current. And then at that point you add whatever conventional currents are there. Right? Then that gives you the final answer. Clear? Right. Voltmeter, ammeter, these instruments are used to measure currents and voltages. These instruments are used to measure currents and voltages. Right?
And the conventional current caused due to like a negative charge and positive charge are equal in the magnitude. Like a positive charge, conventional current will be equal to what actual positive.
Now see. Now again, it's a complex thing. It is not that simple. Now if you have Q negative charge. Q negative charge means what? Wait a minute. I didn't say point charge. Did I say? No. Q charges. The charge amount is Q. Say now I have 1 liter water. You know 1 liter water? Now I say Q quantity of water. Some water, Q quantity. Q quantity of charge. See, now you carry a bag of rice. Each grain of rice you can consider it as charge. Each grain of rice you can consider it as charge. Got it? Now don't misunderstand me. Understood? So charge is one quantity. If I say there is charge Q, if you have seen the previous diagram, I said consider n, small n number of quantity, and each quantity has got charge QE, small QE. Small q into n, nq gives you big Q, which is the total charge. Each rice has got mass m, each grain of rice has got small m. There are n amount of grains. So what is the amount of rice? N into m. Here it is n into q. So nq charge cross this point. See, this contains nq charge. nq positive charge. And now this is the surface area. This nq charge crosses the surface area. There is some current. How much is the current? nq charge divided by how much time to cross. That gives you the strength of electric current. Now nq negative charges are there. It crosses this area. Then in time, so nq divided by delta t gives you what? Some current, natural current. Now negative charges have got. So the conventional current will be this. Understood? That's the quantity. Okay. And I give you the statistics of all the units that I'm going to use here. Alright. So electricity. Now we are introducing one more new term called electricity. Electric charge, electric current, and electricity. All are not the same. So electricity is a physical phenomenon, right? That means there are material objects involved here, particles involved here, matter involved here. Electricity is physical phenomenon associated with presence and motion of matter, right? That means there is some matter which is in motion, and that matter must have property. And electricity is related both to magnetism, both being part of electromagnetism. And we are going to learn something about Maxwell's equation. Just like how you have Newton's laws of 3 laws of Newton, there are 4 laws of Maxwell. Right? So for mechanics, Newton is the father. So for electromagnetism, Maxwell is the father. Alright? So that is electricity. So see, that means there are many physical phenomena, and all that physical phenomena can be explained because of the charge when it is at rest or when it is in motion. Okay? And some of the phenomena I have already shown you. Right? Some of these phenomena I have already shown you. This is quite common phenomena that you have seen. These are all common phenomena that you see. Right? Okay, now yesterday I have explained these terms. Left side you read. Near the surface of Earth you have got EG R cap. I suppose you can understand what is EG R cap? Hello? That I have explained. Then the gravitational force FM R cap is equal to MEG R cap. I suppose you understood the term. If you have doubt, you ask. Quickly ask. Don't create doubts. I have explained this in detail yesterday. Right? And to lift the object, you will apply force. That also I have explained. Right? And work done is equal to manifest in the form of potential energy mgh. And then if m is left free, it starts accelerating and gains kinetic energy. And now come to the right side. Right? Right side also you have similar to what I have written on the left side. Imagine spherical body of mass v minus charge q. So here there is mass m. Okay. Here there is charge minus q. Instead of earth you have got minus q. And then it creates electrostatic field EE R cap. There it is gravitational field EG R cap. Here it is EE R cap. Okay, exactly same. So here you are using mass small m. Here you are using charge small q. Here this charge q experiences electrostatic force. Here the mass m experiences gravitational force. Here also the equation is same. FQ R cap is equal to QEE R cap. Here it is FG R cap is equal to MEG R cap. I suppose exactly same. Got it? So what is the right side? Electric field. Left side it is gravitational field. Now here
Here there is electrostatic force.
FQ is electrostatic force.
And EQ?
EQ is electrostatic field. See, man, can you not apply your mind? See, I have given such a nice corollary here. You try to understand by reading. You don't want to read. That is a problem. This I have given you as notes for you people to read and come to the class. You are seeing this for the first time. That is why your eyes are so wide open. You have not read my notes. If you have read and try to study, you would not have asked this question. Anyways, I can. You are you. See here, EG I explained yesterday. What is EG? Gravitational field. You understood. Here it is EE. Electrostatic field. Exactly same. There also arrows were like this. Here also arrows are like this. Exactly same. Here mass, here electric charge. See, I am showing this analogy so that it is easy for you to understand. Right. Now comes your syllabus. Now here, this has got potential energy. Hello? Yes. Now forget there is earth. Can you forget there is earth? Forget. Instead of earth, I have got charge minus q. Can you imagine? Instead of mass m, you have got charge minus q. And then I have got this body without mass.
So without earth also you have taken without mass, only charge to minus.
Only charge q.
Yes.
Only charge q, no mass.
Yes.
And I have taken this object without mass, only charge. Get it?
Yes.
Now, so what is this? Minus q. What is this? Plus small q. This is large q. This small q is very, very small compared to large q. Conditions I have established. I can actually establish the conditions. Okay? I can call this object by any name. Tom, Dick and Harry. Right? I can create. Right. Now, you see, this is positive charge, this is negative charge. So, if I leave my hand, what will happen? It will get attracted and consequently it will get accelerated. Right? Now, if I want this object to come here, what should I do? I have to apply force. The force I am applying is mechanical. But against what force I am applying force? Understood? Against electrostatic force I am applying force. So work done by me is F external into H.
Yes.
Yesterday I did no F external into H. What is the work done by electrostatic field? Yes, very good. Minus F E into H. So this pen at this point has what? Has electrostatic potential energy. Bolo? If this is earth, this will have gravitational potential energy. If this is charge, if this is an electric field, this will have electrostatic potential energy. See, the term potential energy is common to both. So, if we can have a general definition for potential energy. What is the general definition of potential energy? I will define once. Okay? It is the negative potential energy of this body is the negative of the work done by conservative forces. Gravitational field is a conservative force. What is the work done on this? Supposing this is earth, mass m. What is the work done by this? See, what is the force acting? mg. mg is down. So what is the work done by gravitational force? Minus mgh. What is the work done by it? Can you see minus mgh? What is the potential energy of this body? Minus of minus mgh. Negative of the work done by the conservative force. Then this becomes mgh. इसी प्रकार negative of the work done by the gravitational, by the electrostatic force becomes electrostatic potential energy. Okay? Clear? Have any issues? Don't have issues. Please understand. See, this is how things happen, you know. You apply force and the point of application of force for which you expend energy. Energy is neither created nor destroyed, right? So this energy has to go somewhere. It will go into this object in the form of potential energy. Is it clear?
Yes, yes.
So,
Electrostatic force is also conservative.
yes, exactly. Very good. I was about to tell that point. Electrostatic force is also
Conservative force.
now remember, electric force may or may not be conservative. Electrostatic force is conservative. Understand? Now please understand this. Charge at rest has some properties. Charge in motion has some properties. So the electric field can be created by charges in motion or magnetic field in motion. electric field can be created by magnetic field in motion. You will learn that later. But that electric field created by motion of magnetic field is not conservative. But electric field created by static charge, as charge is at rest, home, that will create electric field, and that electric field is called static electric field. That's why we use the word electrostatics. And this electrostatic field is conservative. Means now if you do work in this conservative field, either I move it like this or I move it like this, the work done is same. It is irrespective of the path chosen. ಇಷ್ಟ ತಿಳ್ಕೊಳ್ರಿ, ಇದು ಬಹಳ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅದ. ಇದಕ್ಕೆ ದೊಡ್ಡ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಫಾರ್ಮುಲಾ ಅದ, ಡೆಲ್ ಕ್ರಾಸ್ ಡೆಲ್ ಅಂತೆಲ್ಲ ಯೂಸ್ ಮಾಡ್ಬೇಕು. ಅದೆಲ್ಲ ನಿಮ್ಗೆ ಇನ್ನೂ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಕಲಿತೀವಿ. ಈ ನಾಟ್ ಇವನ್ ಇನ್ PUC, ಯು ಲರ್ನ್ ದಟ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ in after PUC. But if you are doing mains and IIT and NEET, then you have to learn that mathematics, which I will teach you, if at all I teach you in PUC. You got it? So at this stage you understand the work done in conservative field is irrespective of the path. Okay, so therefore you understood electrostatic potential energy, you understood gravitational potential energy. Hello? Yesterday I taught one more term. What is that? One more term I taught. Hello? Somebody is alert? After I taught potential energy, I taught one more concept. Birthday party. ಮರ್ತು ಹೋಗ್ತದೆ. ಸಿನಿಮಾ ನೋಡಿರ್ತೀವಿ, ಮರ್ತು ಹೋಗ್ತದೆ. Potential ಅಂತ ಕಲ್ಸಿನಿಲ್ಲ. Potential energy per unit mass. Yes sir, push sir. See now. Now, yesterday I taught you like this. This is mass m. A body here at height h of mass m. It has got potential energy of this body is what? mgh. Correct? And then I taught one more term. What is it? See here. If I divide this whole thing by m, that term on the left hand side is what? Yes, potential energy per unit mass. Mathematically, this I call it as potential at a point. At what point you are placed? At that point, potential energy per unit mass at that point, I get a number. That number is simply a value. But what is the physical quantity? The physical quantity, potential energy per unit mass, is called potential. The physical quantity, potential energy per unit mass, is called potential at that point. ಈಗ ನೋಡ್ರಿ, ಕೆಲವೊಂದು ಟರ್ಮ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತೀನಿ, ಆಮೇಲೆ ಅದ್ರ ಯೂಸ್ ಗೊತ್ತಾಗ್ತದೆ. You will understand the use of that. Understand? See, supposing now they show you a knife. What are the uses of this knife? There are many uses. So, as they explain the uses, you will understand what is knife. At the end of many uses of knife, many different uses of knife, so you will know what is knife. So, it is not necessary that you should try to understand what is knife in the first instance. It's not something to be by-headed. So, potential energy per unit mass creates another physical quantity called potential. Potential at that point. Now, right hand side, what happens? It simply becomes GH. Got it?
Yes, sir.
Hello?
Yes, sir.
Mass.
Mass cancel. Hey, no, you have some problem. You better correct it. See, for your sake, I wrote like this today. Yesterday I had written directly Vg is equal to GH. Then you got confused. Then I wrote mass and all. It took 3 minutes. Today in front of you I have written. Oh, see, this is the thing, that's why Gayatri is a good teacher. Because she does this. Very nicely she writes and does this. So that's why all of you enjoy. And I have to presume you know. Right. This is a problem. Anyways. So now it is clear?
Yes.
That happens. Right. So Vg is equal to 0. Now let's look at the interpretation of this. G, what is G?
Acceleration.
Magnitude of the acceleration due to G. Correct. What is H? Height above Earth. Right. Now, supposing I will keep the mass here. Okay. Okay. That is now here you see, instead of keeping mass m, if I keep unit mass, instead of m, then what will I get? I'll still get Vg is equal to Gh. I am experimenting with some mass m. Instead of mass m, I will keep unit mass. Then I will get Gh. Hello? Supposing I kept unit mass here. What is the potential energy or what is the potential at this? What is the potential energy at this point? Hello, loud. Gh, isn't it? What is the potential at that point? Understood? So the potential at this point and the potential at this point is same. This is also a distance h. This is also a distance h. And here, this distance is also h. What is the potential at this point? Here. So like that, how many points will I get? And if you take the set of all those points, what will you get? By if I take a set of all such points, see, you listen to the question. If you take the set of all those points, what will you get? If you get, see, now this is one point at a distance h. This is another point at a distance h. This is another point at a distance h. This is also another point at a distance h. How many such points are there? Now, if I take all those infinite points, what will I get? What will I get? Circle Allah, sphere. You'll get what? Sphere. Understood? So, can you imagine Earth and can you imagine a sphere? What is sphere? Collection of all the points which are equidistant from a fixed point. So, a sphere has got all points. And what is the potential at all these points? So, such a surface, I will call it as equipotential surface. Equi means same. Equipotential surface. Yes.
Where the potential is same on that place, that is on that sphere, sir, where the potential is same, that is known as what is
No, what is the confusion? I told, now can you imagine a sphere, imaginary sphere, and at all the points on that imaginary sphere, the potential is same. Did you get it?
Yes.
And what is the potential? GH. Correct? What is the confusion?
What did you call that?
You said, what did you call? Equipotential surface. Equi means same, potential surface.
Yes.
Correct?
Yes.
Right? How many equipotential surfaces will be there?
So it varies with H.
It varies with H. See, that is how you should think. It varies. See, now the potential at this point is GH1. I will call this as H1. H1. Okay? Hello?
Yes, sir.
I will imagine another sphere. H2. So what is the potential of that sphere? GH2. So this I will call it as V1. This I will call it as V2. Any problem? Hello? So now I understood that this plane has got some potential. This plane has got some other potential. Got it?
Yes, sir.
If you take Earth, this has got some potential. The body here, this point has got some potential. This point has got some other potential. Now, if you consider the acceleration due to gravity to be constant over a region, then which is at higher potential? This plane or this plane? Understood all of you? So this is that higher potential, this is that a lower potential. Got it? Got it?
Yes,
If you have any question, ask now, because I am going to the next step. All smiles are repeating.
So in 2 minutes, can we think about it?
No, not 2 minutes. It doesn't need 2 minutes. It needs 2 seconds. This is mass m. This is at distance. So now, sorry. Now this radius is same. Radius is same. This distance is h, and this distance is h. See, now listen here. What is the potential at this point? What is the potential at this point? I will call it as V1. What is the potential at this point?
V2.
Clear?
Yes, sir.
Now use your common sense and science and tell. Ready? Study 4. What is the potential at this point?
Zero.
Good. 0. Sirish, why you didn't say?
So I was thinking.
So much you should not think in life. Right. Okay. So its potential is 0. Got it? So that means the potential of this point is 0. The potential of this point is V1 with respect to 0. With respect to that surface. The potential at this point is V2 with respect to this. Got it?
Yes, sir.
ಈ ಏನು ಬೇಕು ಅಂತ ಥಿಂಕ್ ಮಾಡಿದ್ರೆ ಏನೋ ಡೌಟ್ ನೀವು ಡೌಟ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿ ನಾನು ನಿಮ್ಗೆ ಏನೋ ಡೌಟ್ ಇದ್ರೆ ಕೇಳೋದ್ರ ಅರ್ಥ ಏನ್ತೀನಿ ನಿಮ್ಮ ಮನಸ್ಸಿನಾಗ ಏನು ಡೌಟ್ ಐತಿ ಕೇಳ್ರಿ ಅಂತ ನೀವು ವಿಚಾರ ಮಾಡ್ರಿ ಒಂದು 4 ಡೌಟ್ ಕೇಳ್ರಲ್ಲ ಇವತ್ತಂತಲ್ಲ now you got it. Okay, I draw the diagram. Now is it clear? Don't feel bad because I am racing against time. If I don't finish by 11:30, I am done. Conductor resistance ಎಲ್ಲ ಕಲಿಸ್ಬಿಟ್ಟರು potential difference. Mahabharata. See, understood?
Yes, sir.
Clear? Understood all of you? Potential. हाँ. ऐसा किया ना आपने? नहीं. जैन ने ऐसा किया. हाँ. सही सही. पता है. ठीक है. Now see. Now understand one thing. Now please understand. Now if I keep a mass here and leave my hand, what will happen?
So it will accelerate. So start accelerating.
So it will move from this surface to this surface.
Yes.
I'll use the word move here. It will move from that surface to that surface.
Yes, sir.
If I keep a mass here and leave my hand, will it go to upper surface?
Yes, sir.
Sure?
Yes, sir.
Mass moved from higher potential to lower potential.
Yes, sir.
मास सी दिस इज अनदर वे ऑफ टेलिंग. देखो एक 2 तरीका है. एक फोर्स करके एक्सप्लेन करने का है, दूसरा वर्क पावर एनर्जी कॉन्सेप्ट्स यूज करके एक्सप्लेन द सेम मैकेनिक्स. I have created, see, from force only I have created potential energy. Now I am using potential to explain motion. Motion can be explained using forces. Now motion can also be explained using potentials. So here you see the mass can only move from higher potential to lower potential. Okay? Understood?
Yes, sir.
This is the law of the nature. This is the law of the nature. Right? I don't want to elaborate now because you use a term, then the whole class will start discussing that. Similarly, now instead of earth, if I have charge minus q, and here I keep plus q. So what is this? What is V2? V2 becomes electrostatic potential. Mass cancel. Instead of mass, if I keep plus q, and this is minus q. So what will happen?
It will run from.
ನೋಡು ಅದ ಹೇಳ್ತಿರೋದು ಎಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕು ಅದನ್ನ ಮಾಡ್ಬೇಕು. ಹೇಳ ಈಗ ಇಲ್ಲಿ ನಾನು ಪೊಟೆನ್ಶಿಯಲ್ ಇಟ್ಕೊಂಡು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡತ್ತೇನಿಲ್ಲ. ಅಟ್ರಾಕ್ಷನ್ ಯಾಕೆ ಬಂತ ಅಟ್ರಾಕ್ಷನ್ ಯಾಕೆ ಬಂತ? ನಾನೀಗ ನೋಡು ನೀನು ಇಲ್ಲ ಇಲ್ಲಿ ಮೈಯಾಗ ಖಬರ್ ಇರ್ಬೇಕು. ನಾ ಹೇಳ್ತಿರೋದು ಅರ್ಥ ಮಾಡ್ಕೊಡ್ರಿ. ನೀವು ಮೈಯೆಲ್ಲ ಖಬರ್ ಇರ್ಬೇಕು. ನೀವು ಸಾಲ ಕೂತಾಗ ನಡೆದು ಕೂಡಬಾರ್ದಿಲ್ಲ. ಈ ನೋಡಿ ಮೈಯಾಗ ಖಬರ್ ಇರ್ಬೇಕು. ನಾ ಹೇಳ್ತೀನಿ ಇಲ್ಲೇ ಚಾರ್ಜ್ ಕ್ಯೂ ಇಟ್ರೆ ಏನಾಗ್ತದ?
It will
move from here to here. Correct now?
Yes, sir.
A charge moved from higher potential to lower potential. ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ಇಲ್ಲಿ ಫೋರ್ಸ್ ಬರ್ದಿಲ್ಲ. ಸಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳು, ಫೋರ್ಸ್ ಇಂದ ನಾನು ಇನ್ನೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ವಿ. ಈಗ ಆ ಕಾನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನಾನು ಕಲಿಸ್ತೀನಿ. ಸಿ ಸೈನ್ಸ್ ಹಿಂಗ ಕಲಿಬೇಕು. ಈಗ ಯು ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ gradually that the problems become very complex if you try to use force and solve. But if you use energy, then you can explain the physical phenomena easily. So you will use easy method, no? You will not make it. See, we want to understand the phenomena. Which method you use? You will always go for an easy method. Hello? Yes. See, when you are sick and when you are recovering, the doctor advises you to eat that food which is easily digestible. Correct, no? Yes. He will tell you halu bread, idli. Okay? He will not ask you to eat some bolgi or kadabu, okay, which is difficult to digest. Chapati, no, it is difficult to digest food. Understand, no? Like that, it is easy. So using this concept, we are going to explain. With force also we can explain, man, what you told is not wrong, it will get attracted. But here attraction is not important.
Yeah. Because that is other concept in this.
For something else that is important. Yeah. For something else this is important. You understand? In life also you see, we are using the right terms, terminologies, right concepts for the right things. You cannot use that for this for that. Yes. And life becomes simple. Okay? Right. So, charge moves from higher potential to lower potential. Is it clear?
Yes, sir.
Let me test. Ready, study, po?
Yes, sir.
Ready, study, po?
Yes.
Now, instead of minus q, this one is plus q. This one is plus q. Instead of minus q. Right? Hello?
Yes, sir.
Now, which is at higher potential? This point or this point?
This point.
Below one is at a
Higher potential.
How did you say? Wait a minute. How did you say?
Because they both are going to repel. So that is the higher thing.
No, correct. Your answer is correct. But on what basis you told? So instead of minus q, I will plus q here. Now, if this is plus q, now what is the potential of this? What is the potential of this? Okay, still you say this potential is V1, still you say this potential is V2. Still, hello?
Yes, sir.
Still you say the potential is same. Got it now? Wait a minute. Now, if you keep a positive charge here, what will happen?
It will go
It will go from here to here.
Yes, sir.
And what did I tell you? Charge will move from?
Higher.
Using this logic, you can say this is at a higher potential. Using this logic, you can say this is at a higher potential. Got it now? But why it is at higher potential, I will explain in the next slide. In the next slide, you will understand why it is at a higher potential. I'll give you a formula. From that, you will understand why it is at a higher potential. Clear?
Yes, sir.
Now, did you understand? Now, what is the difference between these two potentials? What is the difference between those two potentials? ಇವತ್ತು ಯಾಕೋ ಸನ್ನಿಧಿ ಸುಮ್ ಕೂತ್ಬಿಟ್ಟಿಲ್ಲ, ಏನಾಗಿತ್ತಮ್ಮ? ಮ್ಯಾಥ್ಸ್ ಕ್ಲಾಸ್ನಾಗ ಹೆಂಗೆ ಓದಿರ್ತಿರ್ತೀರಿ ಎಲ್ಲರೂ ನೀನು. ಸೊ ದಿಸ್ V1 is a potential, V2 is another potential. V1 minus V2 is called potential difference. ಏನ?
Yes, sir.
ಇದು ಒಂದು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ನೋಡಿ, ಈಗ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಈಗ ಒಂದು ರಾಡ್, this is one rod. Okay, to this rod, by some means, I will give some charge. There are many methods of giving charge. I give some charge. Hello, are you with me?
Yes,
Yes,
sir.
sir.
Then the moment I give one charge, what happens? It becomes a charged body. Yeah, concept use madre. If you give a rod a charge, what happens? It becomes charged. Now, what is the property of a charged body? It will create electric field. No stage, it will create electric field. Right? Now, I have one more charge. I want to bring and keep this charge here. I want to keep. Then, Can I keep the charge?
No, sir.
I can keep. Can I put this finger in your nose? You say no, I can forcibly put it, correct?
Yes, sir. Yes, sir. Yes.
If I am stronger than you, I can always put it. But you will oppose. Understood now?
Yes, sir.
It is not that it is impossible. It is possible. So I have to push this charge to come here. So I have to do work. See, to keep the first charge, I don't have to do any work. But to keep the second charge, I have to do some work. Are you understanding this?
Yes, sir.
Not the work concept is what I think. Force concept is what I think. Now, to keep the third charge here,
More.
I can still keep. Understood? So I still manage to keep, I can manage to push many charges into the rod. Understood all of you? How much work I did? I did a lot of work to push all these charges. Can you appreciate that?
Yes, sir.
For pushing every charge, I have to do work. And as I keep on pushing more and more charge, more and more work I do. So now here, all that energy I expended to push the charge here. What did I say? I expected to push the charge. Where did that energy go?
It converted into electrostatic potential.
Excellent. So this has got electrostatic potential energy. मालूम अभी देखो अभी एनर्जी से सीखना बहुत आसान है क्योंकि अभी आपने इतना एनर्जी एक्सपेंड किया वर्क किया और वही एनर्जी इज नॉट डिसअपियर इट शुड अपीयर इन सम अदर फॉर्म energy appears in different forms. Now here you are mechanical, you have to use mechanical energy to push. And that got converted into electrostatic potential energy. So now this is a charged body, got electrostatic potential energy, and around it, it has got electric field. So what is the potential of this? Some potential. Hey, what is the potential? Give some name, V1. See, you see students, you know it has got potential, right? Right? Now understand this. See, okay, sorry. Okay, now, so this is the body. So there are charges to this body. Now at the surface, so this whole body has got potential energy. Now the entire potential energy divided by the number of charges. क्या बोला मैंने? Then what will you get? Potential energy per unit charge, and that is the potential on the surface. And if you go here, this surface will be V2, this surface will be V3, this surface will be V4. The potential at different surfaces will be different. Got it?
Yes.
Here on it, the potential at this point is V1. Potential at this point is V2, V3, V4. Understood all of you? So the potential. So there will be potential difference between. Got it? Between one point to another point. Got it?
Yes, sir.
Are you understanding?
Yes, sir.
Now if I keep a positive charge here, what will happen? It will go from here to here. It will go from here to here. All by itself. You don't have to push it. There's difference in the potential between 2 points, and the charge can fly, it will fly. Got it? Charge can fly, it will fly. Got it? Now. Okay, wait. I got the slides actually. Mr. Murthy, be cool.
You told how we should measure that point.
I'll
Potential energy on a point.
I'll show you. I'll show you the next slide. You will be clear. I was so excited I went on showing. I got better slides. You'll understand. Wait. So now, wait a minute. I'll show you the slide. Afterwards, I will ask you a question. So you understood equipotential planes?
Yes.
Already I explained without diagram. Now the diagram is superimposing. Got it?
Yes.
Now, if you drop a body or the glass plate from this height, it doesn't break. If you drop it from a bigger height, it will break. That means this point has got more energy to break the plate.
Yes.
So the things that are at higher potential, at higher level, has got more potential. More potential means it can do more work. That's the idea behind this. So here you see, I used these equations. Now here, MVGH. Now look at the symbol. M is what? Mass. VGH. What is that VGH? Wait, now we are discussing two types of potential.
Electrostatic.
Hey, gravitational potential energy. What does that bracket H stands for?
With respect to the gravity.
At height H is equal to GMM divided by R plus H. What is R? Radius of curvature. What is that? Height of curvature. And there's a minus sign. Can you see?
Yes, sir.
Good. That's the beauty. So my dear friend did like this. That means Earth is pulling. That's why that minus sign is coming. Oh, minus sign nahi ho to Earth is pushing. Minus can matlab attraction. Alma? Ha. Right. Now you see, yum is same both sides.
Yes.
खाट करो
Nice.
नहीं उसके लिए सो खाट करिए तो मुझे क्या मिलेगा VG and H is equal to minus GM by R plus H. Understood?
Yes, sir.
Srish. Now you look at this. VGH is equal to minus GM by R plus H. Right? Now here Earth is positive. Earth is positive. No, Earth has got mass m. Another body of mass m will get attracted. So I am using this formula. Now if height increases, look at this formula. Will the potential energy decrease or increase? It will decrease or increase? See, the formula note will the potential decrease or increase with height? Louder. Louder. Hey, Nilgan, bye lena. Potta bye jigudilla. Come on, everybody there. Nina. Go betara khud ko padanga. Come on, speak. Will it increase or decrease? Huh? Louder. It will decrease. See, students, more the negative number. It is less, no? More the positive number, it is more. Got it? So here, if H increases, the number GM by R plus H will decrease. That value will decrease. But that value will decrease with minus sign. Got it? So if there is minus sign, if H increases, the value will increase. The physical quantity value of the physical quantity will increase. But if there is no minus sign, then with increase in H, it will decrease. That is why if you keep a positive charge plus Q, this is V1, this is V2. V1 is at higher potential, V2 is at lower potential. If you keep minus Q, V1 is at lower potential, V2 is at higher potential. Understood? And this is the root of the formula. Got it? Formula. Now, similarly, VH. Now, this is with Earth. Now, instead of Earth, you use charge. So, this is minus KQ by R. K, see here, universal gravitational constant G. Here, K. K is the constant of proportionality. Q is the charge, my negative charge. And R is the radius of the body. Or you can take R also as the distance from the center. That becomes the potential. So this becomes electrostatic potential due to negative charge. If it is positive charge, plus KQ by R. Understood? समझ गया? Why? Because the standard particle I am going to use is positive charge. So positive charge if I use, it will get attracted. That is why minus sign. Positive charge if I use and positive charge is there here, then we will get repelled, so plus. So I suppose this is clear. Now I suppose all of you understood the concept of potential and potential difference. Hello, right?
Potential difference is the difference between 2 points.
Difference between the potentials of 2 points. Difference between 2 points. Difference between the, see in the exam difference between 2 points and 0 difference in the potential between 2 points. It is a potential difference between 2 points. Clear, friends?
Yes,
right, good students. Now you see, you will get the better idea from this diagram. Now cool. Now I have given you this for you to read and come in home. You did not do that. Now for the first time all of you are seeing. How many of you have seen this diagram? Only this girl, that boy, over.
In the video has also, but I didn't analyze.
Other time ಇರುವುದಿಲ್ಲ. Right. So you can see here, quantity of liquid increases, the pressure at the bottom increases. I suppose you understand?
Yes, sir.
ಈಗ ನಾ ಹೆಂಗೆ explain ಮಾಡೋದು ಹಂಗ ಕತ್ಕೊಂಡ್ಬರ್ರಿ ತಲೆ ಹರಟೆ ಮಾಡಬೇಡಿ. Now you see this diagram. As the mass of the body increases, the gravitational potential of the body at P with respect to O increases, minus Gm by R. The small r is nothing but capital R plus H.
Yes, sir.
I had written there R plus H now instead of that R. So this already I have explained.
Yes, sir.
The potential at point P at a distance R from O is minus Gm by R. Got it?
Yes, sir.
Now, if this is a charged body, see here, positively charged body. Can you see here?
Yes, sir.
So at a distance, at point P, at a distance R, it is plus kq by R. Got it?
Yes, sir.
So if it is a negative body, it is minus kq by R. So this is how, see, all the three are similar. And here, level of water is increasing, the pressure is increasing. Here, the amount of charge is increasing, the potential on the surface is also increasing. Subsequently, the potential is also increasing. Got it?
Yes, sir. Yes, sir. And the last one, both how minus, sir, because if it is both minus, then it will become plus, no, sir, because it is pushing away.
Where both minus?
No, sir, both.
No, wait. See, now here, gentlemen, what did I tell you? See, here, the potential at this point is minus kq by R. That means at point P, if you keep a positive charge,
Positive charge.
hey, this is the value of the potential at point P.
No, sir, that
It is the value. See, first understand what is this K. What is kq by R?
It is potential of that particular point.
Sareg hai?
Potential at that particular point.
Potential at that point. It's a concept, right? Now what is minus kq by R?
Potential at that point.
Potential at that point. Now at that point, if you keep a positive charge, its potential energy will be minus kq by R into 1. You are placing a unit charge. So here what is the potential? Minus kq by R into 1, because you are placing a unit positive charge. That 1 I am not showing here. And if you are keeping a charge, you multiply it by 1. If you keep charge of value quantity 2, then you multiply it by 2.
Can you tell why into one, sir?
Good. So if you have seen the previous slide, you will not ask this question. ಎಲ್ಲ ಮಾಡಿ ಹೋಗಿಲ್ಲ ವಿಡಿಯೋ ಮಾಡಿ ಕಲಿಸಿ ಇಲ್ಲಿ ನೋಡಿ what is potential is mVGH. So Gm by R plus H is potential. Potential at that point into whatever you are placing. What did you place there? Mass. If you place a mass only, it will have potential energy. Man, see, there is potential at this point.
Yes, sir. Yes, sir.
See, there is potential at this point. Correct?
Yes, sir.
There is potential because of Earth. So if I keep my head here, nothing will happen. But at this point, if I keep this body, then this will have potential energy. How much potential energy? Potential at that point into mass.
Yes, sir.
So at this point P, there is potential. If you keep charge Q there, some charge, then it will have potential energy. See, at all these points there is potential. At this point, if you keep mass, it will have potential energy. Got it?
Yes, sir.
See, there is food in front of you. Okay, that is energy. But will you get energy from that? No. If you take it inside and if you are able to digest, then only you will get energy. Digest agriculture alle hai. Okay, understood? Then, now see. This is positively charged body having potential V1. I have already explained this. With the rod. Hello?
Yes, sir.
This is, if you go on pumping negative charges, it will have, it will also have negative potential.
Yes, sir. Yes, sir. Yes, sir.
This surface will have positive potential, this surface will have negative potential. Now, you see. Now, if I keep these two side by side, what is the potential of this surface with respect to this? Hey, I kept two equipotential surfaces, no? V1 and V2, what is the potential difference? V1 minus V2. Howdilla?
Yes, sir. Yes, sir.
So if I keep these two charged rods side by side, what is the potential difference? V1 minus V2. Got it?
Yes, sir.
Now see students, I am just keeping two. See, these two rods are not conductors. क्या बोला मैंने? But they are charged. क्या बोला मैंने? So these two rods are not conductors. They are insulators. They are charged. One positive charge, one negative charge. What is the potential of this with respect to Earth? V1. What is the potential of this with respect to Earth?
V2.
Minus V2. I said negatively charged. Plus V1 minus V2. Got it? Or it can be minus V1 also.
Yes, sir.
Any number. Huh? Hello.
Yes, sir.
What is the potential of this with respect to Earth? V1. What is the potential of this with respect to Earth? Minus V2. What is the potential of this with respect to this? V1 minus of minus V2. So it will become V1 plus V2. The potential difference of this with respect to this is plus V1 into bracket V1 plus V2. What is the potential of this with respect? What is the potential of this with respect to this? Minus of into bracket V1 plus V2. Got it?
Yes, sir.
So what is the potential difference between these two plates? You understood?
Yes, sir.
That's what I have written. So now come to a battery. Battery.
Yes,
sir.
Battery has got two plates.
Yes, sir.
They are charged by chemical action inside.
Yes, sir.
So one plate will acquire positive charge. One plate will acquire negative charge. Right? Now, positively charged plate is at potential V1. Negatively charged plate is at potential minus V1. Now, the potential difference between the two is 2V1. Got it?
Yes, sir.
Sannidhi, did you get it? What you did? ಯಾಕಮ್ಮ ಸುಮ್ಮನೆ ಕೂತಿದ್ಯಾ? ಏನಾಗಿದೆ? ಎಷ್ಟು ಖುಷಿಯಾಗಿ ಕೇಳ್ತೀರಿ? ಕೇಳ. ಏನು ತಿಳಿದಿಲ್ಲ ಕೇಳ.
So like how we did the addition of those.
Oh, you ask ನಮ್ಮ. ನೀವು ಅಂದ್ರೆ ಹೆದರ್ಕೊಂಡೇ ಕೂತಿರೋದು ಏನೂ ಆಗಿದ್ದಿಲ್ಲ. ಯಾವ್ದಾರು ಹಾರರ್ ಪಿಕ್ಚರ್ ನೋಡ್ಕೊಂಡ್ ಬಂದೇನ? ಅಥವಾ ನಾನು ನೋಡಂಗಾತ? ನೀನು ನೋಡಿದ್ರೆ ಹಾರರ್ ಪಿಕ್ಚರ್ ಯಾಕೆ ನೋಡ್ಬೇಕು? ಒಬ್ಬ ಹುಡುಗನಿಗೆ ಕೇಳಿದೆ, ನಿದ್ದೆ ಮಾಡಿಲ್ಲ, ಯಾಕಪ್ಪ ಏನು ಕನಸು ಕಂಡು? ಇರಲಿ ಸರ್, ಖರೆ ಹೇಳ, ಕನಸು ಏನು ಕಂಡಿಲ್ಲ, ನಾ ಬಂದಿದ್ದೇನು ನಿನ್ನ ಡ್ರೀಮ್ನಾಗ? ಹಾಂ ಅನ್ನವ. ನೋಡ, ದಿಸ್ ರಾಡ್ ಇಸ್ ಅಟ್ ಪೊಟೆನ್ಷಿಯಲ್ V1, this rod is at potential V2. This rod is at potential V1 when I say, that means with respect to Earth, this is potential V1, this is with respect to Earth, it is potential V2. Okay? Now, what is the potential difference between these two? See, this is also plus, this is also plus. Potential of this with respect to this. This is potential of this with respect to this. Got it? Then that will be V1 minus V2. Got it?
Yes, sir.
Now, supposing this V2 is minus, then what is the potential of this with respect to this? V1 minus of minus V2. That will become V1 plus V2. ಅರ್ಥಮಾಯ್ತಿ? ಏನೈತೆ?
I understood.
ಇವು ಏನೋ ಒಂಥರ ನಿನ್ನ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬೇರೆ ಆಗ್ಬಿಟ್ಟೈತಿ, ಸುಮ್ಮನೆ ಕೂತಿರುತ್ತೆ. Okay, the potential of this with respect to this is?
V1
Huh.
plus
Okay, now if you have understood, what is the potential of this with respect to this?
V2 minus V1.
Either what is the potential of this with respect to this? Minus V2
Plus
minus of plus V1.
yes.
This becomes what? Minus of V1 plus V2. Minus sign I have taken it outside.
Yes, sir.
Yes, sir.
ये बैटरी में क्या हुआ? This is minus V1, this is plus V1. So the battery potential of this with respect to this will be plus 2V1. The battery potential of this with respect to this is, the potential of this will become plus 2V. 2. The potential of this with respect to this will become minus 2. 2. The potential of this with respect to this will become plus 2. 2. The potential of this with respect to this will become plus 2. 2. The potential of this with respect to this will become minus 2. 2. The potential of this with respect to this will become plus 2. 2. The potential of this with respect to this will become minus 2. 2. The potential of this with respect to this will become plus 2. 2. The potential of this with respect to this will become minus 2. 2. The potential of this with respect to this will become plus 2. 2. The potential of this with respect to this will become minus 2. 2. The potential of this with respect to this will become plus 2. 2. The potential of this with respect to this will become minus 2. 2. The potential of this with respect to this will become plus 2. 2. The potential of this with respect to this will become minus 2. 2. The potential of this with respect to this will become plus 2. 2. The potential of this with respect to this will become minus 2. 2. The potential of this with respect to this will become minus 2. 2. The potential of this with respect to this will
it varies according to which we take with respect to lemon.
See, you don't go by that formula, man. Why you want to go why you want to use that method? It varies with, what is the meaning of with respect to? See, you are taller with respect to your sister, correct? So your sister is shorter with respect to you, correct? See, now I say, I am taller. Is it an absolute statement? I am tall. Is it an absolute statement? I am tall. Is it absolute? No, I am tall with respect to somebody who is short. So this potential is also it is not absolute. It is relative. Understand? See, you understand, this world, is full of things which are relative. There is nothing absolute in this world. Anything, you see, it's nothing absolute. Somebody is good because somebody is bad. If everybody was good, then there is no, the term good and bad will not be there. See, for cockroach, do you use the word good cockroach and bad cockroach? Good mosquito and bad mosquito? No, all will do the same thing. So all mosquitoes which bite you are bad only. Understood? Mosquitoes are bad. Understood now? So like that. Okay? So the potential of this with respect to this means how much this is higher than this. Okay? Okay. No,
So, V2 is a negative charge or the potential is negative, sir?
Huh?
V2 as a charge object is negative charge or the potential is negative, sir?
If you put negative charge in that, the potential on the surface will be negative only.
No, sir, it depends on the big Q, it doesn't depend on that, sir. If that is positive or negative.
Nee adrag ಏನು charge haki?
Negative.
Then the potential will be negative.
But if the big Q is also negative, then it will repel, no? So the potential become positive.
Nee ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ಪಂಟಿ ನಂಗೆ ತಿಳಿಯುತ್ತೆ. You want to go to the sphere?
No, sir.
When she's saying that the big Q is negative and the
ಹುಡುಗ
point
ನಾನು
B
ಗೊತ್ತಾಗ್ತದೆ.
charge is negative.
ಈಗ ನಾನು ನೋಡಿ ಕರೆಕ್ಟ್ ತಪ್ಪಿಲ್ಲ. ನೀನೇ ನಾನು ನಾನೇ. Okay, you are you, I am I. Okay, I cannot be you, you cannot be. Yeah, so the student you are a good boy. Because there are other students who have doubts, they are not asking. But the only thing is you are asking. In that way, you are a better student. Okay. So for you, I have to write everything in detail. Then only you will understand. Okay. If I show some diagram, you will misunderstand. Okay. Right. It's okay. It's possible. It's your quality. I have to accept it. I have to change. So if you charge this with plus Q, then the potential at this point at a distance r. The potential at this point at a distance r will be plus kq by r. ಏನು ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ.
The object is positive charge or negative?
ಯಾವ ಆಬ್ಜೆಕ್ಟ್?
Body of the
ಇಲ್ಲಿ ಪ್ಲಸ್ ಕ್ಯೂ ಬರ್ದಿದ್ದಿಲ್ಲ.
the point
ನಾ ಪಾಯಿಂಟ್ ಪಿನಾಗ ಏನು ಇಟ್ಟೇನಿ?
charge.
ಎಲ್ಲಿ ಹೇಳೇನಿ ಚಾರ್ಜ್ ಇಟ್ಟೇನೆ? ನಿನ್ಗೆ ಇದ ಪ್ರಾಬ್ಲಮ್ ಐತಿ, ನೀವು ಅಸ್ಯೂಮ್ ಮಾಡ್ತೀನಿ ಇಟ್ಟೇನೆ ಚಾರ್ಜ್ ಅಲ್ಲಿ. ಐ ಟೋಲ್ಡ್ ಪಾಯಿಂಟ್ ಪಿ ಇಸ್ ದೇರ್. ನೀನು ಚಾರ್ಜ್ ಆಗಿ ಇಟ್ಕೊಂಡಿತ್ತಲ್ಲ ಅದ.
Two charges I thought.
ಯಾಕೆ ಥಾಟ್ ಮಾಡಿದಿ? ಈಗ ಫಸ್ಟ್ ಸಿನಿಮಾದಾಗ ಒಂದು ಹುಡುಗನ್ ತೋರಿಸ್ತಾರ, ಒಂದು ಹುಡುಗಿನ ತೋರಿಸ್ತಾರೆ. ಅವರು ಹೀರೋ ಅನ್ಕೊಳ್ಳೇನು? ಇಲ್ಲ ಹೌದಿಲ್ಲ. ಒಂದು ಸ್ವಲ್ಪ ಸೀನ್ಸ್ ಆದ್ಮೇಲೆ ಗೊತ್ತಾಗ್ತೈತಿ ಹೀರೋ ಹೌದಿಲ್ಲ. ಅಥವಾ ಸ್ಟಾರ್ಟಿಂಗ್ ಹೇಳ್ಬಿಡ್ತಿ ಫಸ್ಟ್ ಯಾರು ತೋರಿಸ್ತಾರ ಅವ್ರು ಹೀರೋಲೆ, ಫಸ್ಟ್ ಯಾವ ಹುಡುಗ ಗಂಡಸರು ತೋರಿಸ್ತಾರ ಅವ್ನು ಹೀರೋ, ಫಸ್ಟ್ ಯಾವ ಹುಡುಗಿನ ತೋರಿಸ್ದಾಗ ಹೀರೋಯಿನ್. ಹಂಗೆ ಡಿಸೈಡ್ ಮಾಡ್ಕೊಂಡು ಪಿಕ್ಚರ್ ನೋಡ್ತಿ. ನೋಡಕ್ ಹೋಗ್ಬೇಡ, ಏನು ಮಜಾ ಬರ್ತೈತಿ. ನೀನು ಅಸಮ್ ಗಾಡ್ ಮಾಡ್ತೀನಿ, ಅದ ಪ್ರಾಬ್ಲಮ್ ಐತಿ. ಡೋಂಟ್ ಸೈನ್ಸ್ ನ ಭಾರಿ ಸಿಸ್ಟಮೆಟಿಕ್ಲಿ ಕಲಿಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ದ ಬಾಡಿ ವಿತ್ ಚಾರ್ಜ್ ಪ್ಲಸ್ ಕ್ಯೂ and at this point what is the potential at all. I have not kept anything there. Now I will keep something here. For the sake of Aryan, I will keep charge plus q here. Now this plus q will have potential energy k q by r into q. That q will have potential energy. What is the value of potential energy? Potential into charge. Got it?
Yes, sir.
ಅವನು ಬಾಯ್ ತಗೋ ಹಿಂಗ ಕೂತಾನ. ಇನ್ನೂ ಡೌಟ್ ಇದ್ದವ್ರು ಗೊತ್ತಿಲ್ಲ ಕೂತಾನ. ಏನ್ ಡೌಟ್ ಐತೆ ಹೇಳ.
No, sir, that doesn't depend on the big Q, like plus Q.
Which doesn't depend?
That potential of, I mean, typically, if the potential is negative or positive, it doesn't depend on the big Q.
ದೋಸ್ತ ನೀನ ಜೀವನದಾಗ ಉದ್ದಾರ ಮಾಡ್ತೀಯ ನೋಡ ಈಗ ನೀನ ಇದು ಬಾಡಿನು ಈ ಬಾಡಿಗೆ ಚಾರ್ಜ್ ಪ್ಲಸ್ ಕ್ಯೂ ಎಫೆಕ್ಟ್ ಆಫ್ ದಟ್ ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್ is that this body has got potential plus kq. The potential at that point is this. See, the potential at this point depends upon q.
Yes.
And the potential depends upon how far is it done. And the potential will also depend upon the medium done. Understood this? So at this point there is gravitational potential. Do you agree? There is gravitational potential at this point. But what is the potential energy at this point? If I keep a body only, it have no. Similarly, if I keep a charge here only, that charge will get potential energy due to the potential at that point. How much is the potential energy? If I keep plus q here, this charge will get potential energy k q by r. What is k q by r? Potential at that point into the charge.
Potential energy.
That is the potential energy of that charge. Got it?
Yes.
Hello?
Yes, sir.
Huh.
That means kq by r into q, and at the same distance means like another point is
This quantity will be same, no? If you choose this point.
It's like it has a different magnitude of q, so means the potential energy will be different.
You see this formula. If this q increases, potential energy will potential at that point is irrespective of q. See, potential at this point doesn't depend upon this. It will only depend upon this. Understood? It will not depend upon that. That has nothing to do. You know, the potential at this point is something. The potential at that point will not change. Potential energy will be for the object, not for the point. Got it?
Yes, sir. Yes, sir.
In a doubt,
Yes.
Sir, like that doesn't depend on whether any charge you keep that, it will be plus kq by r for positively charged q body.
you keep positive charge. Now you keep a negative charge body.
Minus
Then the potential energy of that will be kq by r into minus q. So there will be minus kq by r. So it has negative potential energy. Positive potential energy, negative potential energy. The concept is negative potential energy is, it is there. Negative potential energy, positive potential energy. See, now, supposing you have a well. Pond. Okay, it's a well. Okay, hello. Well, Bhavi.
Well, yes.
ಏನಂತೀನಿ ಭಾಷೆ ಭಾವಿ ಭಾವಿ ನೋಡ್ರಿಲ್ಲ So now this is the reference point. So the potential of this point is 0. The potential of this point is plus V1. The well, physical well ಹೇಗಾಗುತ್ತೆ ನಿಮ್ಮ ಚಾರ್ಜ್ ಇರ್ತಾರೆ ಮಾಡಿಲ್ಲ and the potential at this point will be minus V2.
Yes, sir. Yes.
Got it?
Yes, sir. Yes, sir.
Then what is the potential of this with respect to this?
V1 plus
V1
V1 plus
V1 plus
V1 plus V2. Got it?
Yes,
The
sir.
potential of this point with respect to this.
Yes.
Sanidhi, what is the potential of this point with respect to this?
Minus of V1 plus
Got it now? Minus of V1 plus V2. Understood?
Yes, sir.
So this negative potential, this is positive potential. अभी ग्रेविटी में सिखाया आप लोग. अभी ग्रेविटी को भूल जाओ. अभी I will take a battery. I will keep the battery potential like this. So this is that positive potential. This is that negative potential. This is similar to this point. This is similar to this point. Got it?
Yes, sir.
So the potential of this with respect to this will be
V1 plus
V1 plus V2. ठीक है? Understood?
Yes, sir.
It is 11:30. I have to close.